Alright guys, here we are with 9.4 notes, day 2. Okay, find the coordinates of the center and foci and the lengths of the major and minor axes for the ellipse with the given equation. Then graph the ellipse. Okay, so we're going another step further than yesterday. I guess last time we at least worked on finding those. They weren't required, but today they will be. Okay, so let's take a look here. From this information here, okay, I can tell this is going to be a tall one because the denominator under y is bigger, so it's going to be a tall one. And my center should be at 5, negative 1. Don't get that flipped around. We're so used to having it be the x and then the y, okay? 5, 1, negative 1. Alright, so let's put that down. We're going by 2, so be careful here. 5, negative 1. Alright, we can put our pretend axes in. Alright, there's our pretend axes. Okay, we're going to stick with calling the number under a, or x. We're going to stick with calling the number under x as our a. So a is going to be the square root of 28, which would equal 2 radical 7, which is 5.3. About our b, the square root of 64, which is just 8. Okay, and our c value, big minus little, c squared would equal 64 minus 28, 36, so c is equal to 6. Pretty nice right there. Okay. Now for me, I think it's almost easier to graph all our points right now from this. Okay, so I'm going to do that, and then we'll go through and actually put down what the actual points are. But I think it's easier to graph them from here. Okay, my A was 5.3. All right, and this was a tall one. Okay, so A is going to go left and right here with the X. So we're already at an odd number here. So 1, 3, 5, and 0.3 is just a little bit past there. 1 to get to that line, 2, 3, 4, 5, and then just a little bit past. Alright, my B is 8. So we're going to go 2, 4, 6, 8, staying in the middles. Alright, we got 2, 4, 6, 8. We can kind of round that out. I know I had almost a perfect one yesterday. No, not my best, but still not too bad. Okay, and now we can go ahead and get our points, what the actual coordinates are there. Okay, my vertices. All right, so if that was 0, 0, my vertices would be at 0, negative 8, and 0, positive 8. Because it's a tall one, so this is going to go in the y's. Leave a little space. My co-vertices, okay, be 2 radical 7 and negative 2 radical 7. So negative 2 radical 7, comma 0, and positive 2 radical 7, comma 0. And my foci, which I didn't graph yet, we'll have to come back to those, would be at, now the foci, the focus points, okay, they are going to follow your vertices. So if your vertices have the numbers in the y's, then so will your foci. So we'll go with 0, negative 6, and 0, positive 6. Okay, and now we put our center in there. We're going to readjust it, okay, because we're not at 0, 0, we're at 5, negative 1. So I need to adjust. We'll put 5, negative 1, 5, negative 1 under all of these. Okay, now I go through and get my actual coordinates here. So this is going to be 5, negative 9, and 5, 7. Does that look about right? 5, 2, 4, 6, 7. Oops, sorry, you can't see that. 5. Then I go up 2, 4, 6, 7. Yep. 5, 2, 4, 6, 8, negative 9. Yep, that looks good. Oh, these are going to be fun. We'll have 5 minus 2 radical 7, comma negative 1, and 5 plus 2 radical 7, comma negative 1. Okay, so for your answers, we want simple or simplest or reduced radical form, but it is nice to have the decimal version for yourself when you're actually plotting that out. And then our foci, we got 5, negative 7, and 5, 5. We'll have to put those on now. 5, negative 7, and 5, 5. Negative 2, negative 4, negative 6, negative 7, and 2, 4, 5. All right. So that's all of that, and we're going to add one new thing that we haven't really had yet, area. Okay, area. And that's going to be our A times our B times pi. So we have 2 radical 7 times 8 times pi. Our area is going to be 16 radical 7 pi square units. All right. Take a look at that and absorb all that in. There's a lot going on there. Okay, you could wait to get these points and then graph it. Like I said before, to me it's almost easier to get your center, get your A, B, and C, and then from there now I can do all my points. Okay, that'd be easier to get the points on the graph, draw your ellipse, and then do this part where you get what the actual coordinates are. Okay? Let's give you a second here to try B on your own. Okay, go ahead and try B on your own. Think about which way it's going to go. You want to find your A. First, you want to find your center. Then you want to find your A, your B, find your C. Okay, and then go through all that stuff we just did. Give that a shot. Okay, so your center is going to be at negative 2, 1. Negative 2, 1. All right. Our A under X here is bigger, so it's going to be a long one. Okay. So our A value should be the square root of 48, which is 4 radical 3. And a decimal there is going to be 6.9. Oh, something we didn't do last time. We didn't get our major and minor axes. Okay? So your major is the tall one. Okay? That is just going to be double this distance. So you're just going to double your A or your B, whichever one that was. So over here, my major axis would be, my major length would be, it was a tall one, it was B. So 2 times 8 up, 8 down. That would have been 16 units. And my minor, okay, 2 radical 7 this way, 2 radical 7 that way, 4 radical 7. Alright, so we can take care of that right now. Okay, we said it was going to be a long one, so the A is going to be my major. That's going to be 8 radical 3, 4 radical 3, 4 radical 3. Okay, my B value, square root of 20. That's 2 radical 5, or about 4.5. So my minor would be twice that. My minor length there is going to be 4 radical 5. What will our C value be? Alright, so C squared is going to be 48 minus 20, 28. So C is going to be the square root of 28. That's 2 radical 7, or 5.3. Alright, let's graph some stuff here. So our center was at negative 2, positive 1. Okay, go ahead and do should have had your imaginary, your pretend axes drawn in. Okay, 2 radical 7, 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 Okay, and then like I said, for me it's easier to do it this way. A is 6.9, let's just call it 7 for our graph here. 2, 4, 6, 7, 2, 4, 6, 7. Alright, my minor was 4.5, up and down here, so 2, 4, and just a touch more. 2, 4, just a little bit more. Alright, so we should have a graph looking like this. Ooh, pretty good. A little flat up here. Oh well. Okay, now it's time to get our vertices, co-vertices, focus points. Okay, so my vertices. Okay, we're going to have, if this was 0, 0, we'd be 4 radical 3 to the left, 4 radical 3 to the right. So we'd have negative 4 radical 3, 0, positive 4 radical 3, 0. My co-vertices, okay, they'd be at 0, comma, negative 2 radical 5, and 0, comma, positive 2 radical 5. And my focus points, my foci, remember they follow your vertices, so that's going to be in the x-coordinate. It's going to be negative 2 radical 7, comma, 0, positive 2 radical 7, comma, 0. And now we go in and do our shift, our translation here. We put our center point under all of these, negative 2, 1. Negative 2, 1, negative 2, 1, negative 2, 1. Okay, let's get our final points here. We'll have negative 2 minus 4 radical 3, comma 1. Negative 2 plus 4 radical 3, comma 1. Negative 2, comma 1 minus 2 radical 5. Negative 2, comma 1 plus 2 radical 5. Negative 2 minus 2 radical 7, comma 1. Negative 2 plus 2 radical 7, comma 1. Okay, can you see how those would be pretty tough to graph? Just like this. That'd be pretty tough to graph. You have to sit here and type them into the calculator, get that decimal, and then go through and graph them individually. I think it's way easier to get your center, get your A, B, and your C, then graph from there, and then come back and take care of this later. Okay? What's our area going to be? We can throw that down over here. Our area, A times B times pi. We'll have 4 radical 3 times 2 radical 5 times pi. We'll have 8 radical 15 pi. Alright. Last problem over here, C. We're just going to get it into the standard form of an ellipse. Alright, we've already done 2 of them from the standard form, getting all the information. This time they gave it to us all multiplied out. We're going to complete the square on our x's and on our y's and get that back into a standard form. And then I'll trust that you guys can get the graph from that afterwards. Okay, let's take a look. You want to get your x's together, and you want to get your y's together. And we're going to kick that 144 to the other side. We're going to minus 144 from both sides, so that's going to be a negative 144 over there. Alright, you got your x's together, your y's together, we kick the numbers over to the right. Okay, put parentheses around there, we're going to complete the square. Alright, we're going to pull that 9 out. Don't want anything on our squared term. We're going to pull that 9 out in front. X squared plus, okay, 72 divided by 9 is going to leave you with 8x plus blank. Okay, on the y's, we're going to pull that 25 out. Minus 6y plus blank. And we still have that negative 144. Okay? So what goes in the blank? Alright, half of this one is 4. 4 squared is 16. 16 goes there. Okay, so I added 16 to the left. I need to add 16 to the right. But I didn't just add 16. That's 16 times 9. Yikes. That's going to be a big one. Okay, guess what that works out to be? It's 144. So that's going to cancel that out already. Okay, let's look over here. Half of negative 6 is negative 3. Negative 3 squared is positive 9. So 9 goes here. And it's 9 times 25. So we're going to have to add a 225 to the other side. Okay, so we complete our square. We got 9x plus 4 squared plus 25 times y minus 3 squared. The minus 144 and the plus 144 cancel out. 225. This looks pretty close, doesn't it? Looks pretty close. Okay. I know that standard form of an ellipse, right, we need it to equal 1. We need it to equal 1. So let's divide everything by 225 so it equals 1 over here. Okay. Lucky for us, these should all work out nicely. Okay, 9 divided by 225. We're going to have x plus 4 squared. 225 divided by 9. We get 25 on the bottom. 225 divided by 25 is going to put us with a 9 on the bottom. Equals 1. Oh, fantastic. Okay, fantastic. And these are some nice numbers, aren't they? All right, we can do this graph pretty easily. We'll get the A, B, and C, we'll graph it out, and then if you want to get those, like the points labeled separately, you can. I'm almost out of room. You guys probably are too. Okay, so we're not going to have room for these, but we can figure out what A, B, and C are. Okay, our center is at negative 4, positive 3. All right, my A, square root of 25 is going to be 5. My B, square root of 9 is going to be 3. And C, big minus little, 25 minus 9 would have been 16. And then the square root of 16 is 4. All very nice numbers. Okay? So, x squared is bigger. 25, that's my A. It's just going to go 5 to the side. 2, 4, 5 in the middle. 2, 4, 5's in the middle. Okay, my B value is 3. So from here, 2, 3 puts it right on the line. 2, 3 puts it right on the line. All right, we can round that out. Ooh, oh, just missed it right there on the top. That would have been a really good one. Okay, and our focus points, remember they go the longest way. C is 4, so we go out 2, 4. There's a focus point. 2, 4. There's one. Bada bing, bada boom. Piece of cake, guys. Okay, if you need that slowed down, of course you can replay this, pause wherever you need it to. Homework for tonight, we're just going to do page 620, 25 to 35 odd. They are long, right? A lot of them are just like this. A couple of them you have to do this first and then do that, so they are long problems. Leave yourself plenty of space. Don't try to cram it all into one page, okay? Space them out. Take your time. 25 to 35 odd. Let me know if you need any help. Good luck.